t-test. Okay, so I'm going to open SPSS for a moment, and I'm going to go back to the example we just had. Okay, and what if I told you that in Boston, we know that the average number of slices that are in corned beef sandwiches on average in every Irish pub in Boston is 11 slices. And I asked you to tell me, let's set up we have a sample in New York. We know it's 11 in Boston. We have a sample size of 16 in New York, and we want to test the hypothesis that there's a difference between the two of them. So let's set up our null hypothesis. Okay, so our null hypothesis is, okay, here we go. So in Boston, we know mu for Boston is equal to 11 slices. Okay, in New York, we know X bar. We have a sample that we just collected in New York, and the sample size is equal to 16. I haven't evaluated it yet. All I know is the sample size is 16. This is a known value. This is from a sample. We're going to have X bar. We're going to have a standard deviation from this sample. The sample size is small, so we're going to use the standard deviation of the sample, but that's going to mean we're going to have to do a t-test, right? Not a z-test. Okay, so I'm going to look at this. Let me set up my null and alternative hypothesis. Well, first of all, what's my null hypothesis? The mean number of slices in New York is equal to the mean number of slices in Boston. What's my alternative hypothesis? They're different. New York does not equal Boston. Did I make a judgment yet that one is more than the other? Just that they're different. So it doesn't matter whether my t-test comes out with a negative number or a positive number for a t-score, right? So let me ask you something. If I were to calculate this now and get a t-score, right, for the difference between when I compare my sample mean and standard deviation, when I work this all out and compare it to the known value of 11 slices, what does my I want to have less than 5% chance of being wrong. I want to have less than a 5% chance of making a type 1 error, rejecting my null hypothesis when I shouldn't be, saying he's guilty when he's not guilty, right? Saying when he's innocent, right? So I can call that a type 1 error, but I'm going to call it an alpha error for our purposes from now on. I want my alpha error, my type 1 error, to be less than 0.05. What is my t-score for a sample size of 16 have to be greater than in order to be able to say that? It has to be greater than, what did we say? 2.13, right? If the sample size were 300, what would it have to be greater than? Have to be greater than roughly 1.97, right? Pretty close to 1.96. If our sample size were 4, what would it have to be greater than? Well, I could go to the t table and look up what value of t represents 3 degrees of freedom for 95% confidence, right? So I can use that table for this purpose as well. When I use it that way, I'm saying that I have a value of t that I have to exceed to be sure that I have less than 5% chance of being wrong. I'm going to give that a name, that value of t. I'm going to call that the critical value. So if I exceed the critical, if my t-score is bigger than that critical value, I'm going to reject the null hypothesis. Okay, well, I'm going to do this the easy way. I'm going to go to Excel, to SPSS, also because we're late. I'm going to SPSS. I'm going to go take a look at my sample again, and I'm going to go up here to analyze. Now, we could do it by hand, again, just like we did before, calculate the mean, calculate standard deviation, the standard error, the margin of error, calculate the difference between the two. I'm sorry, not margin of error, but calculate the difference between the two. I'm going to go up here to compare means, right? So I'm going to compare means. I have a couple of things here. One of them is means. One's independent samples t-test. How come this looks like this? What happened to my, let me try opening the output page here. Window. Okay, analyze, compare means. Compare means. I'm having a reason why I'm having a problem here. Let me try something here. Okay, I'll do this again. So I get an output page. Here we go. There's a bug in my version of SPSS. The tests don't all show up unless I have the output window open, right? Kind of cool, right? Interesting bug. So did you notice how all of a sudden now I'm doing the same thing and like many more tests show up? I'm going to go to analyze. If yours does the same thing, which I hope it won't, if yours does the same thing, open an output window and then do the same thing you were going to do, which is go to analyze, go to compare means. What kind of t-test is this I'm doing now? Is it two independent samples, a sample in Boston, sample in New York? No, it wasn't, right? New York, Boston, we knew. We knew that the value was 11 because we sampled everybody in Boston. We took the average of everybody. So if we had sampled 16 restaurants in New York, 16 in Boston, that would be independent samples, right? But we're doing a one sample t-test. We sample New York and we're comparing it to a known value in Boston. That's a one sample t-test. So right now it's asking me, okay, what's a test variable? Well, it's slices of corned beef in New York. And what are you going to compare it to? I'm going to compare it to the value 11, which is the number of slices that we know to be the true mean for Boston. Okay? I'm going to click OK. Let's see what we get when I complete that. Okay, let's take a look here. And if I look down here, I'm going to do this again so that I can scroll up. Okay, there we go. There's the table at the top here. What's my t-score? Minus 1.98, right? And what is my degrees of freedom? 15. And okay, so what would you say if that's our t-score? What's our critical value? What do we need to exceed for a t-score? Right, 2.13, right? Did we exceed it? No, so we failed to reject the null hypothesis. I'm going to do it again. Analyze, descriptive statistics, crosstabs, compare means, single sample t-test. And this time I'm going to say, oh, they're really generous in Boston. They put 14 slices on their sandwiches. I know that that's a true mean in Boston. I'm going to run this test again. Okay, this time, what did I get this time? This time I got a t-score of 5. Can I reject my null hypothesis now? Am I bigger than my critical value for this sample size? Yes, I am, right? I'm bigger than 2.13. It does, well, what it's saying is that it's comparing our value 10 to Boston's mean of 14, right? So you're subtracting 14 from 11, x minus mu, right? That's what you're doing. Comes out a negative number. It really doesn't matter if it's less than left side or the right side, works the same way, right? That's what we're calling a two-sided test. Remember, we didn't make any kind of judgment about whether it's smaller, if Boston has fewer slices or more slices. We just said different. Our criteria was that the two means were equal or the two means were different. Without any concern initially which one was greater than the other. I'm going to make this a little bit smaller because I want to show you something interesting here also. I'm going to call this 12. See if this will work for me. Okay, what does the t-score come out this time? 2.4. Can I reject my null hypothesis? Yes, because with that big a t-score, I know that there's less than 5% chance I'm wrong if I reject the null hypothesis. One more, I just want to show one more thing before I take in. Well, look at this over here, significance two-tailed. That is the real probability of being wrong if you reject the null hypothesis. Anytime your t-score gets big enough, you're going to see that significance, that p-value, becomes smaller than 0.05. They go together, right? That's the real value. When we're working with a table and working by hand, we don't get a chance to calculate that p-value, right? Because we don't have like a z-table, built into our heads like SPSS does. But SPSS actually calculates the t-score and the probability of being wrong if you reject the null hypothesis, calculates both. So you have a little bit of an advantage. I'm sorry, what was your question?
Answered it.
What's that?
You answered it. I was going to ask you if that's the p-value.
Oh, okay, yeah, that's the p-value. Same thing as the p-value. The probability of being wrong if you reject the null hypothesis. And in order to reject the null hypothesis, we want our chances of being wrong to be less than 5%. Okay, guys? So I think we got to call it a night. Okay. I see people yawning, so I know. Okay. You think that, well, okay. Okay. Hopefully as we go on and we work with some more real world examples instead of this kind of like bogus, really known kind of stuff, and maybe we find some real data, we can make this a little bit more interesting. But now we have a tool. We went from this idea of a confidence interval to an idea where we now, if you can imagine, we have a way of comparing two groups: Boston, New York, America, France, beef eaters, vegetarians, and so on and so on. We have ways of comparing groups. And next week, we're going to get into comparing independent samples, where you can actually do studies where you split people up into two groups, take samples, and so on and so forth, and do some really interesting stuff. Okay, so good night.